Welcome to an ultralight airplane design video from the Ultralight Airplane Workshop. This video is the second part of a video looking at the structure of our ultralight airplane we're calling the UWS-4. In this part and the previous part, we're looking at the major structural design components of our ultralight. We're just looking at the high-level view right now. We're not doing any calculations. We're not doing any numerical analysis. We're trying to get a start on our structural design. And it's easier to get a start if we look at a simplified view of the loads on our airplane. The loads we're looking at are aerodynamic loads, landing loads, and even crash loads. We're looking at how the loads are going to be transferred through the structure, and we're putting in the major components to try to handle those loads, and in particular point loads, locations where we have high stresses on the airframe. And where we have those point loads or those high stress locations, we're definitely going to have to put some structural components in there to handle those loads. In the previous video, and I'll put a link up here in the upper right hand corner to take you to that video, we really concentrated on the wing and the major components on the wing. So it'd be the spars and the ribs. Then we moved out to the forward part of the booms where they attach to the wings. Then I left kind of a cliffhanger where we kind of stopped right where the boom crosses the trailing edge of the wing. And when I was editing this second part of the video and I had it start right where we left off in the last video, it was a little bit confusing. So we're going to back up a little bit and we're going to go over again the forward part of the boom because it makes more sense to have that fresh in your mind as we cover the aft part of the boom. Once we finish with the boom, we'll talk a little bit about the tail. Then we'll move on to the fuselage or pod part of the airplane where the pilot sits, and we'll also talk about the engine mount. And if you haven't seen any of the other videos in this design series for this airplane, I'll put a link up here in the upper right hand corner you can go to, and I'll start you from the beginning of our design. If you've just finished watching part 4A, and you don't really want to re-watch looking at this forward part of the boom again, skip forward to the time in the video that I'm going to show right now. Now, let's get on to the structural design of this boom. So here are the booms. Tail is back here, attaches the booms, carries loads up to the wing. Now, since I want to make these booms detachable, they're not going to be integrated directly into the wing. I've got a little bit of an issue here. I want to have this wing keep its normal shape. I don't want to do any cutouts into this flap that's here. So this area right in here will act a little bit like a split flap where the flap is going to be underneath this boom. So right here and here are attachment points for the boom, attaching to the rear spar, and now it's going to have a single attachment up here where the main spar is. So if I was going to make this sheet aluminum, that would be very difficult to carry those forces through here. The force up here on this one is going to be fairly significant in pitch. It won't be insignificant for lateral forces, but pitch will probably be the highest force. And this distance here isn't very significant, so there would be fairly significant stresses through this area also. So I decided not to do stressed aluminum skins in through this area. I decided to go ahead and add a steel tubing structure in here, and I'll probably cover it with some S-glass fairings because I want to try to fair this in through this area. So let's go ahead and show that. So I've added in here what I think I'll probably do for a tube structure from this area right in here forward. So here are the two rear spar attach points. Here's the front attach point. And then here would be an aluminum bulkhead that would then be aluminum all the way on aft. So obviously this steel structure in here, which would be something like 4130 steel tubing, chromoly, it'd be welded together. And like I said, probably covered with an S-glass covering. And it would be all faired in here to reduce interference drag. And doing this, I don't have to do any cutouts of the wing. So the skin can come all the way out here on the wing, so I don't have any cutouts there. So that should help carry any torsional loads very nicely. So let's talk about the aft portion of the booms. Okay, so I've added a few more things in here. We've added the landing gear, we've added the tail, and some extra bulkheads. So there's going to be a bulkhead here, and a bulkhead here, and a bulkhead right back here. The tail boom won't stick out quite this far, it'll actually come up to here. So just imagine this part here is not really there. So this little central portion here will be a single piece of aluminum sheet, and then this will be another piece coming back to at least here and possibly all the way on back. And the reason I want to have a piece of bulkhead here is this piece of aluminum, this piece of aluminum have to have a place to join, and we're changing the shape from this shape here to this shape here, which is more teardrop shaped. And so we're not having a continuous straight line for these loads. There's a change in this shape here for the loads. Let's look at the side. So remember, Dan said we want to have straight line loads if we can. Well, we're not going to have a straight line load here or down here. So I want to have a bulkhead here in order to handle this kink in the load lines. Now let's move on back here to the tail. Now remember, when we talked about the main landing gear, we want to have it attaching to a spar to handle load. For the tail landing gear, we also want to have a bulkhead to handle load where the tail loads are coming in and transferred into the boom. I want to have a bulkhead right here to handle those landing loads where we're attaching the tail gear. And there's going to be a bulkhead right here where we're attaching the tail. So there's two places we're attaching the tail. There's going to be a spot right up here, and there's going to be a spot right back here where we're attaching the tail to the boom. So we've already covered this last bullet here. We're going to use truss tubing for the boom area right where the wing is, and cover it with some sort of fiberglass cover and make it faired. So we've already kind of introduced the tail. We're talking about where we're going to attach the tail to the boom. Again, like the wing, I'm talking about having aluminum skin on it. That's to help handle torsional loads. I'm thinking of a single spar in the tail. Now this is similar to what was done in the Ultra Cruiser. Now the only spar is along the back edge of the main portion of the stabilizers where we're going to be attaching the control surfaces. The control surfaces, once again, I'm initially going to design all aluminum skin, but I'm going to leave myself the option of fabric covering it. Now the airfoil on those control surfaces don't have a concave surface to them, so it's going to be much easier to fabric cover them if I want to do that. So let's take a quick look at the tail then. So here's the inverted V tail of our airplane. Right here would be the only spar I intend to put in there. So it's right here where the control surfaces attach. Of course, we need to have some ribs in here. I'm thinking the only ribs I need are down here where we attach to the boom. Right here where we have a curve from this vertical section to the angled section. And again up here we have this horizontal section connecting to the angled section. I think those are the only ribs we're going to need. And once again, hinge locations, there's going to be a hinge for the control surfaces up here and down here. And also this is going to be a trim surface back here, so we're going to have a couple of hinges in here. And then right down here at the bottom, in order to handle this shape, this will probably be just a fiberglass covering that we put right down in here. And then finally, I believe there will be some end ribs only on the very ends of the control surfaces. I didn't mark them in here, but basically in the same locations where these ribs are, this one, this one, this one, and this one. Now, the next thing to talk about is the fuselage, or the pod that the engine and the pilot set in. Now, I went back and forth on how I want to do this quite a bit. So right now, I'm thinking of doing a steel tubing fuselage, but covering it with a S-glass skin, which will be nice and faired. Now, this is not necessarily the lightest way to do this. Of course, one option would be to do it entirely in aluminum, but because of the curvature, let's take a look at that. Because of the very complex curves I have on here and would like to have on here, that would be very difficult for at least me to do in aluminum. Now, we could modify it and have it be more faceted. That would certainly be a possibility. And I haven't completely ruled out that possibility. We could still do that. Another possibility would be to do it in all composites. And that would be similar to the way I designed the UWS-1 Ultralight Airplane. Now, one of the drawbacks to doing it in composites is issues when you happen to have a crash. It's always possible to have a crash. Sometimes you could get into a wake vortex of a larger airplane that you're following in to land, and it could cause you to become upset and hit the ground. So what's going to happen to a composite fuselage when that happens? Let's say you hit fairly hard on the nose. That composite fuselage typically, now this isn't going to be true for all fuselages, but typically that fuselage is going to fracture, and you're going to get sharp ends of any beams you have in here that break, and those could easily impale your body. Now with steel tubing, Now they could bend, but they typically won't break into and then have sharp ends that can impale you. Now I'm making some significant generalities here. There are some things you can do with composites to make it less likely to happen. There are some composite fabrics that have things in it like Enagra or Kevlar or some other really toughened fabrics that'll make it less likely that any structural components will fracture in two and have sharp ends that can impale you. So there's some things you can do to alleviate that issue. So at least for this initial design, I think I'd rather go with a steel truss fuselage and then cover it with a really thin shell of some kind of composite. I don't mind if the shell fractures, because if I design this right, steel truss fuselage should keep those sharp ends from coming in and impaling the pilot. Now, of course, this design is completely open. I may change my mind in the future. We might decide to make this entire airplane out of composites. But I'm hoping to make it a little bit easier to build by sticking with aluminum or steel tubing that's pretty easy to weld. And then by making a very simple shell, I'm going to try to come up with a fabrication technique that's pretty easy to make. Instead of having to come up with really complex molds, I'm going to try to come up with a method that makes it very easy to make a thin fiberglass shell that can attach to steel truss. Now, let's take a look at that steel truss. Now, here's an image of what I thought about for doing the truss design for the steel structure in the fuselage. These purple lines here are steel tubed. Now ignore the size of these tubes. I haven't figured that part out yet. There haven't been any calculations done. I did all this placement thinking about point loads and some safety issues. I guess a good location to start talking about this is where the wing attaches to this fuselage. So again, this red area here is our front wing spar. This one back here is a rear wing spar. Like I said before, there's going to be 3 attach points. I want to be able to detach the fuselage and the wing. So my initial thought on this design is the attach points for the fuselage to the wing are going to be right here on the main spar. In order to make this spar as light and as strong as I can, I want the carry through here to be straight. I don't want any cutouts. So our attach points will be right here at the top of the spar. And again, there's one attach point back here on this rear spar. I already talked about that. When we talked about 2 ribs originating from a central point back here, coming up to each of these attach points. Now I've also put a tube in here that will serve nearly the same purpose. So it's possible that either the tube will be redundant or the rib redundant, and I'll remove one or the other of either the rib or the tube. I haven't decided on that, so right now both of them are going to be in here. So this is going to be a load point, and these 2 spots are load points. Let's talk about some of the other load points we're going to have. We'll do the engine last. So we're going to have a load point for the pilot, so the load from the pilot goes into the fuselage. So I've decided that that main load point is going to be transferred from the pilot into the seat and then right down here. So I'm going to have a load point right down here on the fuselage frame. We're going to have a control stick that has to attach to this frame somehow. So I'm going to have a load point right here where this control stick attaches. We're going to have a spot for our pedals to attach to the frame. And that could actually have quite a bit of force in it. I'm intending to have some toe brakes on here. So somewhere in here there has to be an attachment for that. Now I haven't exactly decided how to do that. I believe this bar here will probably take most of that load. There'll be a little pivot point in here. This bar is actually in the middle. So you can see that bar right here. There'll be a pivot point that attaches to some control pedals for the rudders. And then the load for that will attach to 2 locations on the frame, right down here in the middle and right here. Now I do have one possible issue, that any downforce isn't handled very well here. I don't have room to put something in here to handle downforce and transfer that to the rest of the fuselage. So this cross piece right down here is going to have to act a little bit like a beam to transfer up and down force over here to this beam. Let's come back to our left view. Now remember that Dan said you want to have fairly straight load paths. So at least up and down vertically, this is a fairly straight load path through here. This one is not quite as straight, but there really wasn't much I could do about that if I wanted to have the seat have a load point and then have the top of the spar be a load point. Now we're going to come back a little bit more to this truss design up here. Let's go ahead and add in the motor mount back here. So this yellow structure here is my at least initial idea how to do the motor mount. Now the motor I'm intending to use has mount points here and here. There's two mount points. There's a left and right one and left and right one here. So this is actually a bar that attaches to two mount points on the engine. And then it comes over to some structure here and some structure here. So let's take a look at the left side again. So I'm thinking of the motor mount transferring load up to this point and to this point, and then also transferring load down to this point. Now this bar here, its sole purpose is to keep rocking from this direction from being an issue. It's going to take this rocking load and transferring it down here and of course here. It does not handle any torsional load due to slowing down or speeding up of the engine. That's all handled back here. And of course, this also handles vertical load from the front of the engine. This back here handles vertical load from the back of the engine. Let's rotate a little bit. Now this structure back here handles any torsional loads. I may have to add one more cross diagonal in here a little bit to handle some torsional loads and side-to-side loads. Now this one down here can handle plenty of side-to-side loads. I think I'll make it so that this one will have a diagonal and handle a little more side-to-side. And of course, twisting from the top, let's view that. Any torsional loads like this are not going to be handled by these bottom tubes. They got to be handled by these tubes here. We have point loads that the fuselage has to handle here, here, and here. Now I added this little extra piece up here. This is for safety. It has nothing to do with a typical structural part of the airplane. I don't need it for the engine. I don't need it for the wing. Don't need it for the pilot. The reason I added this is for rollover protection. Since we don't have a nose wheel, it's very possible that we could have a nose over situation where you flip over on the back of the airplane. If we draw a line from here down to here, we almost have great rollover protection. Not perfect. If this were to crush in, it would push your pilot's head back a little bit, so it's not quite perfect, but it is going to provide significant rollover protection. But in order to have a little more protection, I decided to do some more work. Let me show that. So here's where we're going to have the hatch for the fuselage. There will be a hinge on one side and latches on the other so that this can flip up. So that's how you'll get in and out of the airplane. And I'm going to have a composite structure, or it could be aluminum, in here. So that will provide some more rollover protection. So now we have a line from here to here, which gives us a little bit better protection if we roll over. So this will be a Lexan windshield that you can see through, so it could crush in just a little bit, but we have much better rollover protection here. We have a place we can attach the mount for the panel here. So again, load transfers. So if we do have an issue where we have a rollover, this is going to have to carry a load down to the fuselage. This will carry a load probably both to the top here of the rollover protection and down here, but we need a point to transfer load here down. I could have picked this location, but I didn't want to do that. I wanted to have structure to help support the canopy, so I decided to come back to this location. So any rollover protection we need will transfer load from here down to this point on the fuselage. Now let's take a look from the top. Now here's a view from the upper left a little bit. We're going to concentrate on these lower truss members to start with. So here's where our control stick comes down. So I have a few diagonals in here. That's going to help fore and aft pressures that are going to happen due to the control stick and the control linkages. And again, I have a dual diagonal here to handle fore and aft pressures from these pedals. And that should more than take care of pushing really hard on those pedals if we're going to do that. Whereas a diagonal that went from this corner up to this corner wouldn't provide any support. So that's why we have dual diagonals here and dual diagonals here. Now we don't have that issue back in this area. So there's a diagonal that goes from here up to this corner here. We don't have to do 2 diagonals for that, and we don't need to do dual diagonals back in this area here. Now remember, Dan said that you want to leave out cutouts as much as you can, but we need to have an area for this pilot to sit in here. Now it would be nice if I could put a cross member here. You can't see it very well, but here on this top longeron area, I do not have a cross member in here. And that's because we need room to get in and out. Our knees need to have room to get in and out. We need room for the hands, for our control stick. So we actually have to leave a cross piece out of here. And of course, there's no room for diagonals in here where the pilot's going to be. So this is actually a weak part of our fuselage. So I need to somehow compensate for that. And that's what I did up in this complicated area right in here. One of the problems we have is this line here, this longeron is not straight. It has a kink in it here and here. It's not straight from this point to this point. Now that's okay here. I have a nice cross piece here. We have supports. This is triangular, so that's not an issue. But we have an issue here because if we hit nose first, there's going to be compression on these tubes up here. So it's like from the top, it's going to be a little bit hard to see. But what's going to happen, since we have a little bit of an outer bend here, this would try to push out and this would try to push out and try to collapse this top part. So the feet would come up, bottom would go down, and your knees would try to come up and hit the pilot. So in order to try to reduce that weakness, what I did is I put this structure in here. The whole idea of this structure is to try to keep this corner from coming out and that corner from coming out. So if it does try to go out, there'll be compression on here, there'll be tension on here, so this would pull up this way and pull up this way, and this structure here will help counter that. It's not perfect. It doesn't have to be very heavy. Since this is in tension, most of this will be in tension also. That's assuming symmetric load. Now if we hit sideways and up, then it's going to be an asymmetric load. So we're going to have to do some analysis to try to figure out what size these tubes should be. Another thing I did to try to save weight, which is a little bit of a compromise on safety, let's look at the top, is I did not make this rectangular up in this area. This is actually a triangle. So if we should hit sideways, let's say a wingtip hits and the nose hits, and the ground is going to hit in this way, this pedal is going to get pushed up this way. And so it's going to get pushed into this beam here. But the force should stop at about this location. So I don't think feet will get crushed at an impact from this direction. So I think that's a reasonable compromise to save weight up here at the front. Well, I think that's a pretty good overview of what I'm thinking about for the structure right now. Now this is pretty fluid. This is about the 4th iteration I've gone through on thinking about this structure. And I'm sure it's going to change in the future. We haven't done any number crunching yet. I may find some fatal flaws in this initial idea of how to do the structure. So it is very likely to change in the future. And there's lots of other ways this could be done. There's lots of other designs out there in the world that are different than what I'm doing here, some that are similar. I'm doing a kind of a combination of sheet aluminum and tubing and some composites, which is a little bit unusual, but I'm experienced in all those 3 areas, so I think I can carry this off reasonably well. But of course, weight will be an issue. So it's very possible I'll scrap this entire design and start over and come up with something different. Now this overview, of course, leaves out so many details. I'm sure there'll be lots and lots of questions on the details. I haven't got to that. It'll be a while before I get to that. We still have some other things we need to consider before we come back and revisit the structural design. And speaking of that, what are we going to talk about in the next video? Well, the last section in Dan's book for this chapter is going to cover fuel tanks. Now I'm going to stick a couple other things in there. I'm going to talk about a parachute and I'm going to talk about a baggage area. So that will be it for the next video. That will finish out that chapter and then we'll proceed on to the next chapter in Dan's book. Okay guys, thanks for watching. Until next time.